I don't know if you've noticed this. Older fighter jets, like the F-16 and F-22, used a fully frameless bubble canopy, but in newer fighter jets, such as the F-35, that design has disappeared. Instead, it uses an internal reinforcement frame. It may not look as sleek as before, so here's the question. Why did the new generation of fighter jets abandon the frameless canopy design? What makes it so difficult to create the perfect canopy? In today's video, let's explore this question together. Let's set aside cost for now and start with the most basic manufacturing and optical challenges. When a fighter jet canopy is manufactured, it usually requires thermoforming. A flat sheet is heated and stretched into a complex three-dimensional bubble shape. But this process has a major weakness. As the material stretches, the highest point directly above the pilot's head naturally becomes thinner. And during thermoforming, even tiny dust particles in the air or microscopic surface defects can leave nearly invisible marks on the transparent surface. In air combat, this uneven thickness and optical distortion can affect the pilot's perception when using the HUD, meaning the head-up display. It can create visual distortion and even affect aerial refueling and landing distance judgment. Even if optical imperfections can be polished, the second challenge is even more serious: bird strike resistance and weight trade-offs. This is a nightmare for fully frameless canopies. When a fighter jet is flying at low altitude and high speed, if it strikes a 1.8 kilogram bird at 480 knots, it instantly generates approximately 54,900 joules of kinetic energy. In traditional canopy designs, metal frames help absorb part of the impact. But in a frameless design, the transparent material must bear the entire force. To prevent penetration, the F-22 uses polycarbonate material with a thickness of up to 0.75 inches. Polycarbonate is highly impact resistant, about 250 times stronger than glass, but it is also very heavy. This creates a significant weight penalty. In contrast, the F-35, which includes a vertical takeoff and landing variant, is extremely sensitive to weight. Engineers added an internal support frame. This allows the front section to use thicker material for impact resistance, while the rear section can use lighter, high-strength acrylic with better optical performance. This approach successfully reduces weight. At this point, you might ask, if it's so difficult and heavy, why did the F-22 insist on a frameless canopy? The answer is close-range combat. A frameless canopy provides a full 360-degree unobstructed field of view. However, in the age of stealth, this design comes with a high electromagnetic cost. To prevent enemy radar waves from entering the cockpit and causing internal reflections, stealth fighter canopies must be coated with special radar-absorbing materials or conductive films. Applying a uniform coating on a large, curved, frameless canopy is extremely difficult. If the coating thickness is uneven, it can create electromagnetic inconsistencies and actually increase radar reflection. Even worse, a frameless canopy is only electrically grounded at its edges. Any tiny impedance mismatch can turn the cockpit gap into an antenna, radiating electromagnetic energy outward and compromising stealth. In contrast, the internal frame of the F-35 acts as a conductive structure, providing a stable grounding path and solving this problem effectively. Finally, let's look at the economics. The large, single-piece polycarbonate canopy of the F-22 has a design life of only about 800 hours. The material surface is relatively soft and easy to scratch. Once the stealth coating wears off or structural fatigue occurs, the entire canopy must be replaced. This makes maintenance time-consuming and expensive. As a result, the F-22's flight cost reaches approximately $60,000 to $85,000 US per hour. The F-35 uses segmented support structures and automated thermoforming processes, greatly improving manufacturing efficiency across the program lifecycle. This approach has saved approximately $125 million. With frame-based designs offering advantages in weight, stealth, and cost, what about the pilot's field of view? Modern technology has solved this problem in a different way. The F-35 is equipped with a distributed aperture system and a helmet-mounted display system. Pilots can effectively see through the aircraft, even looking directly below the fuselage with a full 360-degree infrared view. With this kind of digital vision, a frameless canopy is no longer essential. Looking ahead to sixth-generation fighters, in the pursuit of extreme stealth and survivability, future cockpits may even eliminate transparent canopies entirely. That's it for today's deep dive into fighter jet cockpit design. See you next time.